on our we'll make it available on our YouTube channel, and we'll get that out to everyone as a link after this in case you have to jump off or just want to refer back to it. So my name is Jamie McCutcheon. I am with Rymar Waterworks. I am the founder and principal of Rymar. Just so you know who talked to you, I'm a civil engineer, graduated from Clemson in '92. I've been doing civil engineering with focus on private development and stormwater management for about 30 years. So I've been around for a little bit. We invented the Marley float in 2013, and I am a licensed professional engineer. So I'm currently licensed in South Carolina, North Carolina, and Georgia. So what we're going to go over today, I know the Indiana has just, in the past year or so, or this year, started adopting skimmer requirements. So we're going to talk about the basics of skimmers and how you model those for sediment basins. We're going to go through a specific example for Indiana. And I know we have a lot of, at least signed up. We had several of the MS4 or state folks that had signed up for this, or educational folks as well. So if something's changed on the requirements I'm not aware of, please jump in and tell me. Also, I'm going to ask everybody that's not speaking, if you're not speaking, just to mute, just to kind of minimize the background noise as well. So anyway, we'll talk about Indiana examples, and then we're going to touch briefly on skimmers for post-construction water quality. If you are with an MS4 that's joined us, you probably got an email from us about our water quality filter and asked you to confirm if it would be allowable for use in your areas. We're going to talk about it as well today and why you may want to consider that. So jumping right in, prior to skimmers, we used perforated risers, and they were typically designed with an orifice at the bottom, had a stone check dam in front of them. And the idea was you would draw water slowly out of the basin, give time to settle. But you see from these photos, pulling water from the bottom of the basin results in often discharging a lot of sediment because that's where the sediment tends to accumulate. So skimmers have been around for many years. They've been promoted for use in sediment basins during construction. They meet the requirement for surface withdrawal, or I believe Indiana is calling it floating outlets, which drain the basin from the top down, releasing the cleaner water from near the surface. And skimmers have been shown to greatly increase trapping efficiency. Most basins easily obtain 80%, often up to 90% trapping during construction if they're designed correctly. So this is just an example of a skimmer. It floats at the surface. This is ours. It's called the Marley float. It actually takes water from just below the surface. So it has a ability to stop floating debris from escaping as well. So as one of the benefits of it, has this debris guard around it. There are a variety of skimmers out there. The Fairclaw skimmer was the one that kind of started this, so you've probably heard of them. There's the erosion supply or ESC skimmer, again, the Marley float, or the IES skimmer. So one of the things to focus on is what are the requirements for sediment basins. So this chart talks about requirements for multiple states. We'll focus on Indiana, but I included others just so you can kind of see what other requirements are in other areas. For Indiana, I understand the draft is 5,600 cubic feet per acre, or a 1-year storm volume plus 1,000 cubic feet per disturbed acre, which is below your dewatering volume. Other states, South Carolina, where we're based, has a 3,600 cubic feet per acre requirement. North Carolina, Georgia, and Ohio all have 1,800 cubic feet per acre requirements. Ohio does include that additional 1,000 cubic feet per acre for disturbed area for sediment storage. So, Indiana's standard, at least the draft standard, is a good bit higher than some other states, which is going to make the basins a little bit bigger. And I guess something to look at is, are you allowing water out a little too fast, not retaining that enough to get the settlement time in there. But anyway, that's the standard as I understand it today. Surface area, Indiana is not specified. Other states specify a minimum surface area. So, you just want to make sure you meet that. The principal spillway is going to be for Indiana, the 10-year, 24-hour storm. That principal spillway would be typically your riser structure and your skimmer. So you're not trying to get the 10-year storm handled by just the skimmer. And then you have an emergency spillway to handle anything above the 10-year storm. And where skimmers are required on Indiana is 5+ acres. That does vary. South Carolina is 10 acres. North Carolina is down to 1 acre. And Ohio is 10 acres. So, but typically what we see is anywhere you've got a outlet structure in place, and it's not like a rock check dam, that you want to use a skimmer. And then the dewatering time is the other key factor here. So Indiana, it's 2 to 3 days. The most common standard we see out there is 2 to 5 days. Georgia doesn't have a standard, and Ohio has a 2 to 7 day standard, so it allows a little bit longer. So, and then we also know that local MS4s may have some differing requirements. Typically, these are the state minimum requirements, and then some MS4s may have more stringent requirements if they have, waters of a that they need to protect to a higher standard, or something else that just says, hey, we've got an endangered species or some high quality water, trout streams or whatnot. So you may have higher standards in some areas. Specifically in the 2021 construction general permit, Indiana said sediment basins, where feasible, must withdraw water from the surface of the water column unless equivalent sediment reduction can be achieved by other measures, and it gives some alternative measures. It also addresses freezing conditions, and that is one thing in the more northern states that has been a question is, okay, if you get ice and you get significant ice in your sediment basin, how does the skimmer function? And we do recommend, if you're going to have a significant amount of ice anticipated during your construction, that you consider some alternative drain for those times. You may have like just a valve or something you can open to a perforated riser that allows it to drain. The other measures here, again, this is straight from Indiana draft standards, is to retain the stormwater for a period of 48 to 72 hours. And then your dewatering zone design is 5,600 cubic feet, or you can calculate your volume for a 1 year, 24-hour storm event. And then again, you have a minimum 1,000 cubic feet per acre of disturbed area. This volume should not be included in your dewatering storage volume. That's additional storage volume for sediment storage that you will probably want to put in below the invert of your skimmer. So let's just go through the fundamentals. So the fundamentals of the skimmer basins, number one is, what is your dewatering volume? Again, we talked about that, 5,600 cubic feet per acre. So if we run that, say an example, 10-acre site, got 56,000 cubic feet. And again, you got the additional 1,000 cubic feet of disturbed area, or you can calculate that based on the Russell equation. And again, we do emphasize, do not include that in your dewatering volume. You're just going to make your skimmer bigger and drain that other volume too fast. So dewatering time is your fundamental number two. Again, Indiana is 48 to 72 hours. And then based on those two factors, you're going to determine your flow rate for your skimmer. So using our 10-acre, 56,000 cubic foot volume, a 2 to 3 day range. So you're going to want to pick a skimmer between 28,000 cubic feet and 18,700 cubic feet per day, with that flow rate for that skimmer. And if you do that, you will meet your 2 to 3 day drain time for that required volume. One thing to point out, especially if you're just learning about skimmers, is skimmers are not all equal. Georgia commissioned a TRI Environmental to do a study on skimmers when they were updating their manual. And they tested 3 different types of skimmers, and I use this as a good example. This is 3 different 3-inch skimmers. You'll see their test tank is 4 feet deep, so flows go from 1 foot to 4 feet. And 2 of the skimmers are pretty consistent. They're around 37 GPM, while the third one is almost double at 70 GPM. And the other thing you'll notice is that all 3 skimmers had an increase in flow from 1 foot to 4 feet of about 25% of their flow rate. So these two were still fairly consistent, around 50 GPM, one just under, one just over, but the other one, again, is nearly double at 90 GPM. So the point is, if you just simply say a 3-inch skimmer and don't say the brand or anything else on your plans, you may not get the skimmer you're wanting. And you may, if you intended to have one of these skimmers do it, you may drain the volume too fast. If you intended to have the other skimmer, you drain it too slow. So it's important to focus on flow rate, not just skimmer size. And so we have a really simple design tool on our website. For Indiana, we'd recommend using the one with a permanent pool. And we worked closely with Ohio in developing this tool because they had they were seeing some common issues with engineers when they were going through this. So very simple up top. You got the date, your project name, location, the company name. If you have, engineer name in there, if you want to include the individual basin description. Obviously, some sites are going to have multiple basins, so basin A, 1, 2, 3, whatever it may be. So we're going to have in here your required sediment storage. So that's based on your disturbed area at 1,000 cubic feet per acre. So that's going to be 8,000 cubic feet, assuming like an 8-acre site. And then a required dewatering volume, again, based on the total acreage going to the basin. So in this example, 5,600 cubic feet per acre or 56,000 cubic foot volume. Then you come over here to your inputs. The tool has a minimum and maximum time to drain. So we plugged in the 2 to 3 day drain time. The pond depth is going to be the depth controlled by your skimmer and the depth required to get to this calculated pond volume. Then you have a top length and width and a bottom length and width. And we try to get at least a 2 to 1 ratio on those. Sometimes if you can go a little bit longer, 3 to 1 or 4 to 1 is preferred, but generally we try to shoot for at least a 2 to 1 ratio. And using the pond depth and the length and width, the tool will calculate the pond volume. And we're trying to hit a 24-hour range, right? So don't have to spend all the time to get this to exactly 56,000 cubic feet. So here we're at 56,550. So that's pretty close to our 56,000. That's pretty reasonable. It will then calculate the drawdown time for every skimmer with each orifice configuration that we have. And then you click on the skimmer report page here at the bottom. And that'll take you to a nice, neat 8.5 by 11 sheet that will give you the information that you have. So at the top, you're going to have this check here to confirm your required dewatering volume and your calculated dewatering volume are close. So that, for the reviewers that are here today, that's a just quick check to make sure that the skimmer sized correctly based on what's required. You're going to have your minimum and maximum flow rates here. You're going to have all the information that you put in on your, to determine this, readily available. And then because it's our tool, we're going to give you which skimmers meet your required time. So in this case, we had 2 different options. We had our 6-inch with a 3.5-inch orifice or a 6-inch with a 4-inch orifice, range of 52 hours to 68 hours. So the engineer can pick either one of those, whether they want to drain a little slower, a little faster. But really simple Excel tool available on our website. There's no sign up or login or anything to download that. And we intended this to be a simple page you can print out, include in your SWIP, or we often see engineers include it in their plans to give that information. Again, anybody that has any questions as we go along, we've got a fairly small crowd, about 20 people or so. So if you do have a question along the way, I'm happy to stop and answer. Again, on our website, we have some standard details. These have been developed based on looking at multiple states and kind of incorporating what we see. And so you got a, sediment basin criteria based on the state here. So that's, what's the minimum length width ratio? Some have a maximum. You got that sediment storage, dewatering volume. In this case, it should be 5,600 cubic feet, not 1,800. Surface area if it's required. And here you put in your minimum and maximum times. Again, that's going to be 48 to 72 hours, not the 48 to 120. Your sediment storage volume. So you're just going to show that you meet your required with your provided, and your dewatering volume, you're required and you're provided here. So just make sure that you meet those requirements. Then here you're going to have your drainage area, disturbed area, your flow, surface area of your basin, and then all your basin information. So what's your bottom elevation, the outlet invert information. So here you've got, some storage, sediment storage below your invert. So those are different. The barrel pipe, top of the riser, et cetera. So the key thing here is your skimmer size, your skimmer orifice diameter, your skimmer type. I know we've got the Marley plugged in just because that's ours, but they can change that if they need to. Is an equal allowed, yes or no? Most of the time that's a yes, but not always. There may be some reasons why you want to have a certain skimmer required there. And then what's your skimmer flow rate. Go ahead and set your minimum and maximum. And that way, if the contractor does want to use a different skimmer, as long as it falls within that range of flow rates, it should be approved without having to go through a whole lot of review time to confirm that. Real quick, we'll go through some skimmer installation photos, just some things to look for. Again, understand in Indiana, they're not quite as common. So one of the things we want to look for here is this pad. Okay, most places specify some sort of a stone pad for the skimmer to rest on. The detail that we have specifies a depression, because what you're going to notice here is that pond was graded and it looks good. They tracked in the sides, they got their baffles, everything's looking pretty good to start with, except that then they put the stone in, and that means you're going to have, if this was intended to be a dry basin, you're going to have water ponding in there. Now in Indiana, with your sediment storage volume, you're going to end up being a wet pond. So this should always be sitting below, and you're probably always going to have a little bit of water ponding in there. We've seen some really bad installs. So this came from an inspector, I think in Ohio, but the contractor just did about everything possible wrong in this picture. And then sometimes they even put them in upside down. And so, they put it upside down. They didn't put in near enough room here for the skimmer to float up. Again, a lot of things wrong by the contractor. We do have reps that cover our states, and we also work with our distributors. We typically sell through like Core & Main and Ferguson and other local waterworks suppliers. And we try to train them so they can tell the contractors. But if you ever see a bad install, please reach out to us and tell us, hey, we'd be glad to reach out to the contractor and help them do it right. Last picture here is a maintenance item. So if you ever see vegetation growing out of the skimmer, it probably needs some maintenance. This one had a big root ball growing in it. So they're not maintenance-free items. They do require maintenance occasionally. So that's kind of covers the very basics of skimmers. The other thing we want to focus on today is permanent use of skimmers. And I was told by someone that, and haven't found this in the regs yet, that Indiana was looking at incorporating some sort of floating outlets for permanent use as well. And so we'd really encourage that. We know we still have to address the freezing issues, but skimmers can be really good for maintenance. So you'd want to consider them, for permanent use, because number one, basins are designed to capture pollutants by allowing time for settlement. That's been the standard for water quality, is you hold that first flush volume and allow things to settle. And so if you're going to do surface withdrawal from permanent retention or retention basin, it's going to release the cleaner water from near the surface and get more time for pollutants to settle. It's become a fairly standard practice during construction. And so it doesn't make a lot of sense to do that during construction and then post-construction take out the skimmer and then pull the water off the bottom again. And then the other thing is low flow water quality orifices often need to be 3 inches or less in diameter, and they're very prone to clogging. So a skimmer can provide a similar flow rate. It can have a larger orifice because it's got less head, and it's going to be much easier to get to reduce clogging. So the other thing is some skimmers like ours withdraw from just below the surface. Therefore, the floating pollutants such as oil, grease, trash, and debris are not discharged by the skimmer. But also one thing is PVC material should be minimized. PVC is not UV resistant and will become brittle and crack within a few years. It is also more likely to crack in frozen conditions when freezing is a concern. So this is a quick example of how skimmers can help with maintenance. This is a site we did in Simpsonville, South Carolina. It was really overgrown site. The pond was in bad shape. Turned out that there was a 2-inch orifice about 6 feet below all this muck. And so we redesigned the pond to use a skimmer instead of that 2-inch orifice. This was a pilot project in South Carolina, so we were required to monitor it for every month for the first year and then quarterly for the 2 years after that. And about a year after we put this in, they were maintaining the pond, but they did not get all the debris out of the pond. It had about a 5-inch rain in just a few hours, and you can see all the debris that came down here that got to the pond, to the basin, and to the outlet. And the skimmer was still able to to drain the pond down without getting clogged. Last thing about this, we've used this pond as kind of a guinea pig. We're doing R&D to test a filter to go around the skimmer to be used for post-construction. And so some of the benefits to using skimmers with filtration versus using the settling process is the skimmer can be sized to control the peak rate for the lower storm events. It also increases the filter efficiency by withdrawing from near the surface where the water is cleaner, and it's easy to access for maintenance and changing the filters. However, there are some problems with or challenges with using filtration. The filters are prone to clog over time. That will require maintenance and some periodic cleaning or changing. As we said, your skimmer's got to be durable. It's got to last more than a few years to be suitable for permanent use. And the biggest one, and that's for all the folks here that are with MS4s with the state, there are no established standards for basis of design and permitting based upon a combination of pond and filtration. So what we see is the typical is, your first flush water quality volume being held for a certain amount of time. But if you try to treat that with a filter instead, how do you do that? I'm not sure if we have anybody from Indianapolis on with us. I understand Indianapolis does have a list of approved devices. And to be on that list, the first criteria is you be tested by or certified by NJCAT. We have not had our filter certified by NJCAT yet, but it is tested to an ASTM standard. So Indianapolis has said we've got to may have to change that and allow the ASTM standard before they can allow our skimmer there. But most other MS4s in the state have said this, concept would be acceptable, at least to be considered on a site-by-site basis. So, again, this goes back to our kind of guinea pig site. We've now tested this. We actually did the testing in a lab. It was tested by TRI Environmental, and it was tested to a relatively new standard by ASTM. And it confirmed that we got over 90% TSS removal with our combination of skimmer filter combination. Our filter is a two-stage filter. The outer stage is a polypropylene woven mesh. So it's just basically a big screen. And the inner filter is a non-woven material called Adsorbate. It's great with TSS. It also helps with hydrocarbons. It has some benefit for metals, and we're hoping it may have some benefit for phosphorus and nitrogen as well, but we have not tested any of those. We've only really tested it for TSS with the skimmer so far. So I'm going to go really quick. Like I said, for those that joined a little later, we accidentally set this up using a different Zoom account, which I apologize for, but we're limited on time, and we're going to get cut off here in about 7 minutes. So I'm going to go kind of fast with this. But we do have training videos that are going up on our YouTube channel, which we'll get into more detail. So go through quickly the modeling for hydroflow. So hydroflow has kind of become the standard for hydrology modeling. And so the main thing there is kind of example site. We have a site that had 2¼ acres being developed, curve number of 86. When you're developing your pond, your stage storage table, what you want to do is you want to put in a stage so that you can put in a flow rate. So in this case, we did 0, 0.1, 0.3, and then a ½ foot up to 4 feet. Then you just take the flow rate from our details, which our skimmer details provide the flow rate at those intervals. And you use the user-defined column to enter that information. So you'd put your standard barrel in, your culvert A. In this case, we had a 6-inch orifice, about 1.75 feet above the bottom, the top of the riser, and the riser had a rectangular weir in the top. But to put in the skimmer flow, we use this user-defined column. And so when you look at your schematic of hydroflow, it's going to look something like this, where you normally would have a low flow orifice here. You don't have that. You've got your other orifices configured in there, but you can see your skimmer flow is here. And so that's the flow rate for your skimmer. So that's just like real quick, not intended to be a intense training course on that, but basic example of how to model and how to flow with a skimmer. The last thing we want to touch on is the filtration-based water quality. And so again, we've done our testing, met 90%, but now if you're going to do that, how do you incorporate that into your plans? So we'll take an example 5-acre site. So let's just say we're going from a wooded condition to a commercial condition and compare how a traditional water quality first flush model compares to a filtration model. So first thing you're going to do is get your flow for your pre-events. Now, most areas it's a 2, 10, 25, and 100. Some areas may require a 1-year storm or 5-year storm or 50-year storm be included, but whatever it is for your local area. Then you're going to determine your post flow, prior to detention. In this case, we also ran an event for a 1-inch runoff volume, which is kind of typical in South Carolina as far as the first flush. Some states require 1.2 inches, some have other volumes, but it equated to 18,000 cubic foot volume for this pond, and that was our pre-development flows. And then most engineers use some sort of spreadsheet and then calculate that low flow orifice. They assume that that entire first flush volume magically appears in the pond instantaneously, and then you size the volume to drain that down over 24 hours or so. And so in doing that, and then we plug this stuff back into HydroFlow, we ran the model. And what's really interesting here, we have a water quality volume of 18,000 cubic feet, but our water quality storm is only using 10,000 cubic feet of that volume. But typically you can't put a second orifice below that water quality volume. So you've got some area in there that, or some volume in that pond that, is not really being fully utilized. Go fast through that. So we want to compare that to using a skimmer. So again, we had a 0.72 flow rate for our 2-year storm event. So we picked our 6-inch skimmer with a 6-inch orifice, which has a 0.78 CFS flow rate at 4 feet. This was the detail for the skirt, how it would go around the skimmer to provide the filtration. And then this detail for the pond about what it would look like with the filter in there, with the skirt in place. But we ran the same volume here. And so instead of worrying about retaining that first flush, we just said, hey, let's try to control the 2-year storm with our filter skimmer. And the advantage here is now we're treating all the flow, not just the water quality storm, but all the flow from the 2-year storm and below is going through our filter. So we're now treating a larger amount of annual rainfall. The water quality event only needs 7,500 cubic feet of volume, but we're still detaining all the other storms as required. And then if we compare that, the difference in storage required for the water quality event is almost 30%. And on the other storm events is somewhere in the 12 to 15% range. So in effect, you are making your pond smaller, but you're treating more of the annual rainfall, and you're actually treating it fully to a 90% TSS removal rate. So in our opinion, this is a win for the developer. They're retaining more land. It's a win for the regulatory community and for our environment because we're treating more of the rainfall. And hopefully it's a win for the engineers because we've now got a product that's easily shown to meet those requirements. So the last thing we're going to run through is just quickly on our website, just to kind of tell you how to find this information. We've got about a minute and a half remaining here. So if anybody does have a question, please chime in. But the design tool is, again, you go to the Marley Float design spec cut sheet page. We have a design tool without a permanent pool. We have one with a permanent pool. We have our details in CAD and PDF. You're free to download those and edit as needed. If you scroll down this page, you'd see the pond details as well. We're in the process right now of uploading our water quality filter. I was hoping that would be done today. I reached out to my web folks. They haven't quite finished it, so hopefully by first of next week, all that will be there. If you need it sooner, please email me, and I'll be glad to get it to you. We have our standard details, and then we have just some information about our skimmer. Again, it's a HDPE product. It has the debris guard to keep out any floating debris. It will work in mild frozen conditions as we take water from below surface about 4 to 6 inches. But if you're going to get a foot of ice, it's going to freeze and get stuck, and it's just going to sit there until it melts. We have a unique orifice configuration where we have this orifice plate, and so you just rotate it, and it allows you to change your orifice size very easily. And then this is our models. We have 6 different models, range from our 2-inch